Okay, hello YouTube once again, and today we are going to try to take out the motor from one of these 4.8 volt cordless drills and use it in a linear actuator for my various robotics projects. We have some screws here that we got to take out, but we also have this label which also contains a screw. There's screws on either side, screws on either side. This is what keeps the gearbox connected to the motor. All the screws on this side, and all that's left is this last screw. Just let me show that there is in fact screws under this label. Peel off the label, screw right there, and this should free up the case, which will reveal all of our components. This does use two different kinds of screws. On these four edges it uses thin screws, and on the rest of the case it uses these thicker screws. You can see how they compare in size. Yeah, so that's... We are going to have to reuse these screws though. Dump this out to reveal all of these components, but you can see this motor, nothing's holding it on. So this is completely useless right now for a geared motor. In order to correct this, we have to use some of this case as well. But we're going to take out some parts. Let's look at what we've done. So we've cut off the handle. Now we have this, which will be our motor housing. So basically we're gonna put it back together as if we were using this as a normal drill, just reassembling it. Looking at the motor, we are going to use this as a DC motor, so this does mean that we are going to cut it off at the wire leads, leaving only positive and negative. Positive and negative, we will wire these to a separate wire, which will go out. This remaining assembly also has a switch, nickel cadmium batteries. These are actually AA batteries. You can take them out, and we have an LED. So we will use that later. But first, we need to understand how our motor will mount. You might want to do this differently. You could easily zip tie it, especially since it has this groove here, if you want to use it to, for example, power wheels. But I'm using it as a linear actuator, so it's going to have to go like that, which will require a mounting point. I'm going to drill this out at 1/4 of an inch, so we can have a 3-inch bolt screw in there. Right now it probably does screw in there a little bit, but it is blocked by the end of the housing. See, as long as you hold the two pieces together, the drill works fine. And we're just going to slide this bolt in here. It pops out at the other end. It would be a good idea to use washers here, but I just ran out of washers for my robot, which I used the washers on the arms, legs, and head, which I just built. So let's get all the plastic bits, shavings out of there. It's important to keep the plastic away from the interior of the motor because it has gears and you don't want it getting in the gears. So we are left here with a motor, which we need to run wires to. These wires are too short, let's get some longer wires and connect that up. I found a wire. This is an old lamp cord, I think. So you can see the side that has a smooth and the side that's rough. So the smooth side is going to be positive, the rough side is going to be negative. That's a common way of doing it that I found. Okay, so now we have our wires here and the motor is all screwed together. I actually found some more washers, so that was good. This bolt is tightened. So all we need to do is mount our shaft for the linear actuator. What this is going to be is a 7-inch by 1/4 inch threaded rod connected to this plate of metal, which is zip tied to 2 nuts. I already explained how this works in some of my robotics videos. These are on the legs and are going to be on the arms with this actuator, which we will make now. So what we're going to do now is connect this. This slides in here. There's a magnet back here, so that's good. Held in by magnetism. The next thing we are going to do is hot glue it around there. And we have to use a lot of hot glue. We're going to get some more zip ties and we're going to go around there. The idea is that the hot glue will act like a rubber and it will grip onto it under the tension of 2 zip ties. We are going to place these here and then we are going to cover the zip ties in hot glue. It may be better to use epoxy if you were to do this. I'm using hot glue just because it's fast and cheap and it has worked as previously mentioned before. But this is not to say other materials will not work better for you, especially in different applications. So now to test our completed linear actuator, let's try it out with the 4.8 volt battery. Once I'm done with this, I'm actually going to take these batteries out and use them as the main power source for the entire robot, since I have so many of them now. Let's just connect them up together and pay attention to this piece as it moves across.